Hello and welcome to the Oxford Mathematics Online Open Day in May 2025. My name's James. I'm the Admissions and Outreach Coordinator for Maths at Oxford. It gives me great pleasure to welcome you to this online event. It's great to have you with us. I think I'm live. I think I'm on YouTube. If you're watching this, you can get involved as well. So, for example, today, here's a quick look at the process. We've got a 10 o'clock overview of Maths at Oxford, the joint honours courses and the admissions process. That's with me. And then at 11 o'clock, I'm going to be joined for a Q&A session with tutors and students. I've got some of our current students along. I haven't made them get up for 10 o'clock on a Saturday. I've made the students get up for 11 o'clock on a Saturday. I've got some tutors coming as well. You can get involved with that over at slido.com, slido.com/oxmaths for short for Oxford Maths, or if you head to slido.com and put in that event code. I can see people are already putting Q&A in there. I'm going to do my best to give you a look at the, for example, overview of the courses and the admissions process during this first hour, so that hopefully I've already answered some of your questions before we get to the Q&A section with all those tutors and students. But do join in with the Slido if you want to ask something or say good morning or whatever. Then you can join in there. I've got it open on a second monitor while also running this. So I'll mostly use that later on for the Q&A. But if you have any concerns about the open day this morning live on YouTube, you can get in touch via the Slido, or of course by contacting us via the usual channels, like our email address, which is on the Open Days page. I'm assuming that people have found this from the Maths Open Days page. If you've joined us through some sort of YouTube link, then welcome to this corner of YouTube. There are more resources and much more information on the Maths Department website. There's a link in the YouTube description, and lots more links coming up later on as well. There's quite a lot of stuff on the web. I'm going to try and highlight some things that are on the web, but also give you some links to read lots more. Right. Okay, I think we're off and away. So let's have a quick look at what maths is like at Oxford. If you'll allow me, I've got some photos to start off with. This is the Andrew Wiles building. So I realise we're doing this online rather than in Oxford. If we were doing this in Oxford, we'd be in the lovely Andrew Wiles building. I've got some pictures here showing the Penrose tiles out the front. Penrose is a mathematician who works in Oxford. Worked on these aperiodic tiles. We've got some out front. There's a photo of what it's like inside the building on the left there as you come in. Downstairs is where we have lots of lecture rooms. I've got some photos later on. Upstairs is where we keep our researchers and academic staff. It's quite nice having everyone together in the same building. It means that we've got staff and students all together in the same place, which I quite like. Students from all of the different colleges, by the way. I'm not going to say too much about colleges today. If you get a chance to visit Oxford, then you might visit a college or two. When you're applying, you get to name up to one college, but whichever college you live at and whichever college you're affiliated with, if you're a maths student in Oxford, then you have maths lectures together with the maths department. Everybody gets the same course options. Everybody gets the same degree options at the end. Everyone gets the same maths, which is what I really care about. Good, okay. So lovely building, home of maths in Oxford. Staircases inspired by that one MC Escher picture. I don't know if you know, with the three staircases going round in a kind of impossible triangle, and that's because MC Escher, the artist, is a collaborator with Roger Penrose. And these impossible triangles and impossible staircases were slightly the inspiration for our staircases inside, which of course means it's impossible to find your way around, which gives us all sorts of challenges. Right, okay, that's our lovely building. I also want to tell you about the maths, of course. We've got maths courses and we've got joint honours courses as well. So there's lots of things on the slide here, but don't worry about the choices so much as the options. For example, on the board I've got BA and M something options for each of these courses. For historical Oxford reasons, Oxford awards a BA for almost all undergraduate courses. It stands for Bachelor of Arts, but it doesn't mean that it's a particularly art course. It's a it's a maths course if you want to do maths. Nothing arty about it, although we do have those Penrose tiles outside, thinking about it now. Anyway, so for historical reasons, Oxford does BA for undergraduate degrees, that's a 3-year degree, or master's level degrees for 4 years. So we have these MMath, MMath Phil or MMath Comp Sci, these 4th year options. Students don't need to know whether they want to stay for the 4th year when they apply. So if you put in an application to Oxford, then we won't ask you whether you want to stay for the 4th year or not. In fact, I don't even think there are 2 options on UCAS. I think you just say which course you want to do. You used to have a choice between maths and statistics, but those courses have always had the same first year, so we've actually made that simpler as well recently. We run joint admissions for those ones, so because the start of the course is the same and we're looking for exactly the same things, joint applications. On UCAS it's listed as maths/maths and statistics, which means everyone's together in the first year, and then midway through year 2, students choose whether they do maths or maths and statistics. The reasoning there is that after seeing a little bit of statistics in the first year taught in quite a different way from A level or equivalent, some students realised that they would like to do lots more statistics and get the option to switch onto that joint honours thing. So Slido question saying, can we get the PowerPoint afterwards? And yes, we will find a way to distribute the slides afterwards. I think almost everything I'm saying is also on the website, so when I give you links, you'll find subsets of bits of pieces, but if you want all the slides, we will circulate those afterwards as well. Good, okay. Maths and stats. So that's maths and stats. If you know already you like statistics, then that's great, but again, it's not something we ask on UCAS, it's an option later on rather than a question to solve now. If you know you don't like statistics, then don't worry about it. You don't have to do maths and statistics, even though on UCAS you're applying for a course that says maths/maths and statistics, and also you might be one of those people who discover after first year that they do actually like statistics. Right, okay, I've talked quite a lot about the first ones. I want to briefly mention Maths and Philosophy, which is a joint honours course where you do half of the maths course and the study of philosophy alongside. So it's a prescribed half of the maths units in the first year. I'll show you a list of options. Broadly speaking, the more abstract or fundamental pure mathematics from the maths course, together with the study of philosophy, which includes some of the kind of logical underpinnings of mathematics, the kind of reasoning and set theory, but isn't restricted to that. On the Venn diagram, you're not restricted to the intersection of your interests. People do a bit of philosophy from other topics and a bit of maths from other sorts of fundamental mathematics, not necessarily philosophical in nature. So these joint degrees aren't really a restriction to the intersection. They have options from the other bits of the Venn diagram as well. Maths and computer science is like that as well. You do half of the maths courses and half of the computer science courses. And then later on, as those courses have lots of options, which I'll show you, you have some freedom to choose between maths options and computer science options, depending on what you've previously studied as we get further through the course. So they're not an intersection sort of thing, they're a sort of more of a union with some restrictions on what prerequisites you do. Obviously, if you want full access to all of the maths options, then you might need to have done particular things in previous years. Right, okay. I don't think I did a great job of describing that, so I think I'm probably going to get a question about it later on in the Q&A, or even now. If you're in the Slido, let me know if you want me to say something again. Right, okay. I've got rough intakes, although our rule is that we can take, broadly speaking, any combination of students that adds up to pretty much the right total number of students. We're limited by the number of bedrooms that we've got. So I've got rough intakes from previous years, although Maths and Computer Science is on an upward trajectory at the moment, so I think their ambition is to admit much more than 25 students next year, and Maths and Philosophy. Well, Maths and Statistics is complicated because that number refers to what's going on in second year onwards. Anyway, right, don't read too much into statistics. I mean the entry statistics. You're not a statistic, you're an individual. Right, good. Okay, that's an overview of what we've got. We've got joint honours courses, we've got big maths course. Possibly I want to tell you more about what's in the maths course, just to give the idea that there's a real range of stuff in there, if you'll come with me. I've got a list of what's in the first year, for example, where we have a combination of things that you might have heard of. Maybe you're already studying some of these things in school or equivalent, and maybe some things that you haven't heard of. So, for example, we have courses in here about integration, which you probably learn a bit about before university, but in a maths degree, you learn more about the fundamentals of how integration actually works. What are we trying to do? Which functions can we integrate? And that takes quite a lot of theory to develop answers to that question of what can we integrate. In first year, there's a course here to give you one definition of integration, to define it properly, and that lets you integrate certain functions. And there's a second course in second year, I'll show you in a moment, where you get a chance to take that further with a different definition that lets you integrate more functions. But we're really trying to get down to the underlying definitions, the kind of logical roots of what's going on behind all of these things. So maybe you do some vectors, maybe you do some geometry, but we would like to start again from fundamentals and try and build things up. And that's partly because mathematics is a very cumulative subject. We want to have these kind of core solid foundations to build on later on, and also because, well, we've got people from all sorts of previous educational backgrounds. We don't want to assume too much about what you've seen before. In general, people have seen quite a bit of maths before because they're doing maths A-level, perhaps, let's say maybe further maths A-level as well, usually, if they're doing A-levels, or things equivalent to those. But we like to teach maths without assuming that you've already seen lots of theory. We'd like to build the theory with you. We also have courses on the applied side of things, looking at applications of all this maths theory, so that once you've built the theory, you get to do things with it as well. So first year we teach you to solve these things called partial differential equations, which turn up all over the place in quantum mechanics, in fluid dynamics, wave theory, sound, light, electricity. The idea about there is that by understanding equations first, you can then understand lots of different applications which maybe happen to have similar equations. If you get really good at equations, then the applications are easier. Is this webinar also catering for mature students? Yes, I think so far. I've described maths courses. For mature students, you follow the same application process. We understand that you might not be currently doing A-levels. I'm trying to say or equivalent as much as possible. But you follow the same application process and you get to study the same courses, so I think I'm on track. I'm not covering graduate courses. I'm sorry if anybody's waiting for me to get onto how to do a PhD. This is undergraduate today. I should have said that earlier. If you've joined to find out what DPhil courses we have a DPhil. You can find out more on the graduate section of the website. I'm so sorry that I've started from year one. I'm only going to get to year 4. Good. Okay. And yes. So this is the same I've said before for maths and stats. And maths and philosophy students would take things like algebra and group theory things, but not the, can't remember this, not the partial differential equations side of things. So there's a question about flexibility in the Slido as well. It's a good question. There's that route that I've described for switching between maths and stats, because in first year we don't expect you to know which of those courses you're on. It's slightly harder to switch between the other joint honours courses, just because if you are trying to do maths and computer science, there are lots of computer science units that you wouldn't have been doing, and the right to switch is not automatic between those joint courses. That doesn't mean it's impossible. It means it's a discussion between a student and their tutors to work out could they catch up with this course. In general, the further away the course is, the harder it is to make that happen. If you wanted to switch from maths to chemistry, that's really, I never say never, but would really require quite a lot of catching up. If you wanted to switch from maths to maths and stats, that's trivial. So there's some sort of distance calculation in there. So in first year, it's all of these things, I know, and each of them is quite large. This is the thing about studying maths full time for a year. You can learn quite a lot of maths. I haven't really got a comparison to if you're doing A-levels at the moment, and I know not everyone is doing A-levels at the moment, but let's imagine that you're doing A-levels in 3 things at the moment, maybe maths, further maths, and chemistry or something. In that case, you're spending maybe 2/3 of a school day doing mathsy sort of things, maybe half a school day, maybe 2/3, maybe some other things going on in your life as well, which is good, of course. You can fit a lot of maths in if you're doing maths full time for 3 or 4 years. So yeah, you do all of this in first year. Maths and CS students do half of this. And again, it's the more abstract things. So linear algebra is really important for maths and computer science students. Although, do they do a special? Yes, they do linear algebra. Come on, James. Of course, it's how machine learning works. Right, okay. But again, less of the applications to, on the right there, dynamics, things like Fourier series, not for maths and computer science students. So maths students, everything on the board. Maths and philosophy, about half. Maths and computer science, about half. Maths and statistics. Great, okay, the Slido is going. So now I'm going to have a look a little bit here. Do people who do joint honours miss out on some aspects of each courses? Yes. You don't miss out on any of the depth of the things that you're doing. So if you do the linear algebra course, you do all of the linear algebra course on that bullet point. You don't miss out on any depth. You get literally the same lectures. You get the same exam. But you miss out on some of the range of things. For me, I really like the kind of Fourier series, sort of solving problems with the heat equation and having applications to fluid dynamics. So for me, I wanted to see as much maths as I could, which is why I did maths at university. But that means I missed out on all of the computer science, right? So it's very hard to do more than one degree. Nobody does that. But the joint honours course, the idea is you're combining 50-50, at least in the first year. The numbers I showed you for students were roughly speaking, and they did include everybody. I'll do requirements and admissions. Admissions and requirements coming up very soon, once I've shown you what you're applying to do. Worth knowing what there is before we get into the nitty-gritty of how to do it. Right, okay. I'm going to move on to year 2, I think. There's a whole year of stuff which is skipping past. So in year 2, there's quite a lot of things, and we start having optional courses in second year. I quite like this because the students have now had time to try some things out to see what they might be enjoying the most, what they want to learn more about. And although we have a few core courses, things that we still think everyone should know. For the math students, that means another course in linear algebra, this time getting further down into the kind of fundamentals of what's actually going on with addition and multiplication. There's sort of some common themes that come up in lots of different mathematical structures. And if you can spot the sort of themes and transferable knowledge, then you can get down to this more abstract layer where you understand lots of different settings all at once. That's kind of the selling point of maths, I think. You get to be able to solve 2 totally different problems by realising that they're actually the same problem. Anyway, good transferable skill as well, of course, for later in life. Anyway, there's some options on, we've tried to pick up things that you might be interested in learning. So topology is the study of shapes under deformation. So looking at things like how a donut and a coffee cup have got kind of the same shape if you're allowed to deform things, but not the same shape as a football because you can't get rid of the hole through the middle of the donut. It was that sort of donut. Number theory is really big in Oxford. We've got lots of people doing interesting work in number theory. So we have some number theory courses, including an optional one in the second year. You can learn about facts about whole numbers and prime numbers and things like that. And then other things you probably haven't heard of. The ... includes lots of courses somewhere. The names aren't going to make any sense at the moment. But lots of things. We're trying, broadly speaking, to catch people up with all of the maths that's happened since the stuff that you do in A-level or equivalent, and the cutting edge of things that are going on today. So there's quite a lot to catch up on. For example, mathematical biology. You don't really do any of it in A-level, that's for sure. And then it's turning out to be quite a big thing. So I'd like to show you some of that mathematics. I haven't put, so yes, question. Somebody in the chat is doing my job better than me, I think, because they've put an advert in the Slido. For the 4th year Maths and Theoretical Physics, which I haven't even listed on my slides because you can't apply for it on UCAS. But there is a 4th year Maths and Theoretical Physics course, which might be interesting for people who are choosing between maths and physics. You can do that after doing 3 years of maths or after doing 3 years of physics. But of course, I hope that you will choose 3 years of maths first, picking all of this sort of quantum theory stuff within the maths degree. There's some of it there, look. And then taking that in a physics direction. There are lots of other master's courses, too many for me to put on my slide actually, doing things like computational maths and fundamental foundations of computer science, and sort of all of these things. There's a really interesting list. Graduate study, loads of things going on. Again, if you want to do a DPhil, then sorry, I'm not talking about DPhils today. And a wider world after that, just to answer Hector's question in the Slido. The wider world for that is, if you go on to do research or something, then research crosses the boundaries between these things anyway. And people might find that they're doing their research later on, and if you go into this world of academia, you might be in an engineering department doing some machine learning, you might be in a physics department doing some fluid dynamics, you might be crossing all sorts of interdisciplinary boundaries. There are no prerequisites for specific courses. Yes, so we've designed it so that if you're admitted for the maths course, we're looking at maths, and then we teach it to people who like maths. So if you want to do mathematical biology, you do not need to know anything about biology. If you want to do quantum theory, you don't need to have done physics A level. If you want to do machine learning, you don't need to be able to code anything. It's sort of, we will teach people this. And again, this is later on in second and third year. So by this point, we've had lots of time to teach people lots of things. Yeah, with admissions questions coming in as well. Let's have a quick look at this. The admissions questions about UKMT, which we'll get to. Okay, just catching up with things over there. How much finance and investment is there? We've got a little bit. So we've got this course on financial derivatives in the third year. I wouldn't describe our course as having a lot of finance or economics. There are options at Oxford to do things like economics and management, if you're interested in that. And there are options at other universities to do things like maths and finance. Or I think you can do actuarial science as a degree course at some universities, I think. But our course has got a little bit of that from a very theoretical point of view. Black-Scholes is sort of mathematical object, really. It definitely is. And there are ways to do that in a really sort of academic way. If that's not what you want, then I think there are other courses that do that differently. Okay. I want to describe our teaching very quickly. Here's a picture of a lecture room as advertised. That's the largest lecture room. We've got banked seating, lots of whiteboards at the front. If you'd like to see a sample lecture in progress in that room, we've got a video recorded. We've got quite a few of these actually on our YouTube channel. I've picked out one of them and put it on the Open Days page. I've picked out Introduction to Complex Numbers because I like complex numbers. It's a good lecture, and I think it demonstrates all of the things that we try to do in lectures. That's on our main YouTube channel. I now realise that I'm doing this on our second channel, Oxford Mathematics Plus. So if you're looking for lots of recordings of lectures, we've put quite a few up on our main YouTube channel. Good. So typical structure, we do lectures, maybe 10 a week, Monday to Friday, in the Maths Institute. The lectures include problem sheets that are set for the students to try outside of that lecture time. So 10 hours of contact time is not a lot, but then problem sheets mean we give the students things to do so they can go and think about it, which usually involves looking back at what happened in the lectures, thinking hard about the content, learning it, and then trying some problems, getting stuck on the problems. In the first 2 years, we support that with tutorials as well, which is small group teaching, maybe 2 or 3 students and 1 tutor. I'm currently a tutor at New College, and I see my students in pairs, and it's a chance for me to give them feedback on the work that they've been doing. They hand it in and I mark it. And it's also an opportunity for me to tell them what's coming up next, or to show them things from a different point of view, which might be helpful if they're stuck, and it might be helpful if they're doing well and want to see a sort of more challenging setting for what they've been learning about. We can tailor that to the individuals because although we've got about 200 students coming to the lectures, we split them all up and we organise lots of these tutorials. So for each course that a student's doing, which is that list of bullet points, they can expect tutorials on each of those for the first couple of years. Later on, as we break down to lots and lots of options, we have larger intercollegiate classes where people come together from different colleges and have a class that's a bit larger to talk about the material and go through the problem sheets. We think this takes about 40 hours per week, but if I'm honest, it's quite hard to count, especially with students. which hours, if you point to them, which hours is this student currently studying, or are they on their phone, or is it a bit of both? I find it quite hard to count that sort of thing. I haven't put activity trackers on any of the students. I think it's about 40 hours. They certainly seem to have time for other stuff as well. So other things like sports and music and theatre are all really big in Oxford. Lots and lots of small student societies doing niche different things. All really nice. Good. I didn't mention computational maths because there's a little bit in the maths course as well. So that's taught through lectures, a bit of classwork teaching people to use Python for the maths course. We don't expect you to have coding experience beforehand for the maths degree. We teach people Python and get them to use that to solve some problems. We are interested in this on the course because we think it's an important skill to have when you leave the course. We don't expect you to know it beforehand. If you're applying for maths and computer science, then you're probably interested in writing code a little bit and trying things out like that. Good. Question about Scottish students applying to anything bands. So we think the A's are all the same. I will show you our standard offer for Scottish students in about 10-15 minutes. We think A band 1 and A band 2 are all about the same. Is there a college which is particularly good at maths tutorials? Now, obviously, I'm biased, right? Because I do some maths tutorials at New College. All the tutorials are on the same problem sheets. They're covering the same material, and they're all great. All the colleges are the best for maths because we're all doing the same maths, and it's the maths that's the best. You can, if you like, look at lists of tutors for who's at particular colleges, but tutors have got a tendency to sometimes switch colleges or leave Oxford, so don't set your heart on a particular college because of who's currently there, bearing in mind that you don't know if they're there next year. That's a disclaimer. Right, okay, let's have a quick look a little bit more about tutorials. As I've said, this is a flexible approach to teaching. Here's a picture of some people having a conversation at a blackboard. They've brought some work along with them and they're now talking it through. This allows us to do things depending on, I can tell people in chat are asking about their different backgrounds, different things about things they're currently studying. And so the nice thing is that we can take that into consideration, especially in that first year tutorials. I'm really finding that some of my students have done physics, some of them haven't, and that's fine because we're teaching things from fundamentals, but you can also show people things from a different point of view and say, okay, don't go and do physics A-level, but there's this one idea in physics A-level that we're touching on, and I want to show you this other way of thinking about it. I don't know. We can bring things into the tutorials. Not a whole physics A-level, my goodness. So I'll do questions. Slido's getting quite busy, which is nice, which means I need to get on with it so I can answer questions. Just to do two quickly, no, we don't have Saturday lectures, Monday to Friday for Oxford Mathematics, and maybe 2 or 3 tutorials a week. Some colleges split them up a little bit more, some colleges do slightly longer tutorials, but broadly speaking, 2 or 3. Lots of time for independent learning, study, and lots of time for other things as well. We are mostly exam-based at the end, so we mostly assess through examinations. There's a dissertation in the 4th year, and a small number of courses throughout the years are examined by a project, but by and large we do exams. There's a photo here of students getting ready for an exam. By old Oxford tradition, they have to dress smartly in this sort of gowns and suits, which means the town is sort of full of people smartly dressed. There they are, ready to do exams. My goodness. Right, mention of computational projects down there again, which again I don't want to scare people with the idea of learning about computational projects. Do try and teach people Python there as well. What GCSE grades are good? Oh, I think 8s and 9s are pretty good, aren't they? It's what used to be called an A star, I think. Person in the chat has posted some GCSE grades. Just be clear, you can't apply through the Slido. I'm going to show you how to apply through UCAS in a moment. That's just a joke. How much of the exam content is based on Python? I have scared somebody about Python, right? Okay, just a tiny bit. So a tiny bit of Python in the first year. I think it adds up to generally less than, I think it adds up to about 10% of the first year. That's maybe an overestimate. I should know that. It's not a large component of first year, is what I'm saying. And first year doesn't count towards your final grade. So students need to pass the first year to do the second year, but some very small percentage of that is based on Python, which again we give people support and help with. Good. Okay, let's have a quick look at admissions, and I've seen some questions coming in chat, so I'm going to try and address some of those as well. One person's asked if you can do maths and music, and I'm really sorry. So we have quite a limited list of joint honours courses, and maths and music isn't there. You can, of course, do maths at university and also do some music. We've got lots of orchestras and bands and choirs and organ recitals and lots of musical opportunities, but not as a joint honours degree. I think that is a thing at some other universities. So maybe if you really want to do maths and music as your degree, then maybe another university is the best university for you to do that. But if you want to do lots and lots of maths and in your spare time do lots and lots of music, then Oxford does a lot of that. Right, okay, yeah, we have a question about supercurriculars and GCSE grades. Okay, right, here we go. Is 8 and 9, what's a good GCSE grade? Okay, right, good. Are we ready? I'm going to do it in sequence, and GCSE grades come in quite early, so hang on a second, and we'll go. Okay, admissions process. Quick overview for why we do an admissions process. We're lucky to have lots of applicants. We have about 10 people per place applying for the maths course. So my numbers here at the bottom are for the maths course in particular, and we have about 10 people per place, PPP, for applying for the course. I'm sorry, the PPP thing made sense when I made my slides. I now realise it looks ridiculous. 10 people per place apply. We have a limited number of places on the course, and we have a limited amount of interviewing resource. So we don't interview all of our applicants. We want to use our interviewing resource on students we think we can maybe make an offer to. We do quite a lot of shortlisting. We make a shortlist for the interviews. So we narrow down the field to about 3 people per place, and then we use the interviews together with everything else that we know to make our offers. We make offers in January, and we're not in the business of making dramatically more offers than we have places. We have about a 10% factor on there, about 1.1 people per place, but by and large, the people we make offers to start the course in October. So the stages there, getting from the application to interview involves things we get from your UCAS application, which I'll tell you about in a moment. Plus also we have the maths submissions test, which is a test that we get all of our applicants to take so that we get some extra information. Once we're going from interviews to offers, we have extra information now because we've interviewed some people. At interview, we ask more maths questions. I'll tell you more about that in a moment. But both of those stages are very mathematical. We're looking for the students with the most potential to succeed on a course that's got lots of maths in it. If you're interested in computer science, then same rules apply. We're still looking for people who are good at solving problems, and that's usually a mathematical thing. So maths and computer science especially, you'll be good at mathematics to get the most out of that. Okay. Somebody in chat wants to reapply. So if you've already applied, then maybe you don't need my information about how to apply. The rule about reapplying is if you're reapplying, then you're treated as if you're a new, different person. We don't link it together. So maybe you can just join in with the slides anyway, because we're not going to link your applications together. So from our point of view, you're just applying. It doesn't get linked back to a previous interview score or a previous math score or anything like that. Good. Okay. So a question in chat about STEP, which we don't use. So you can do STEP if you like, but it doesn't play any role in our admissions process. So we use the maths admissions test instead. STEP happens in the summer, which is too late for us. We've already made our offers then, so we made our 1.1 offers per place. We get down to 1 by occasionally people going to study somewhere else, but not very much. We're lucky, right, that people want to accept their offers when we make their offers. So we have to be very careful to make offers to people we definitely want on the course. Okay, right, let's have a look at each of those stages, starting with UCAS applications. As trailed, I get your GCSE grades from this. There's an early deadline for Oxford, Cambridge, and some courses in medicine and a couple of other things. But if you're interested in Maths at Oxford, there's this deadline 15th of October 2025, and that's applying for 2026 entry. So if you want to start in 2026, then you're applying almost a year before you've started. That means that usually you haven't completed qualifications. Some people might have completed some qualifications. We'll look back at qualifications you've completed in the last 3 years as a measure of what your current preparation is. But normally people are applying before they finish their qualifications. So this is a qualifications you've taken or will take, because some people are still at school. Your UCAS referee, who you'll find either through school or sixth form, or by nominating a UCAS referee yourself, they'll predict grades for us to let us know what they think will happen in any qualifications not yet completed. So at that point in the application, we've got information from UCAS about your previous grades and predicted grades. Let's talk about GCSEs. So we know that your GCSEs were taken quite a few years before you start university. I guess it's 2 and a bit years by the time you arrive at university. And we know that GCSEs are in a variety of different things, whereas if you're applying for Maths at Oxford, then it's a bit like the follow-on from Maths GCSE and not like the follow-on from French GCSE. So people apply with GCSEs that are not perfect. They don't need to be perfect GCSEs. And I'm especially interested in Maths GCSE, of course. But we know that your GCSEs overall, they're not irrelevant. They show us what happens when you do a lot of exams. We've got a lot of exams. But we know that they're not necessarily all in things that you want to do at university. So they're one measure. We do look at your GCSE grades. We'd like you to do well in your GCSEs, of course. But we know that that's quite complicated, and it varies a lot from school to school, from person to person, and from subject to subject within the same person. Different GCSE grades might be more or less relevant. So we can't do this just on GCSE grades, we think. We also want to do a big maths test. And I now have information about the maths admissions test. So we're going to do that. People are asking about interviews already, so okay. So applications haven't actually opened yet. I think we opened the round at some point in the summer. There's no advantage to applying early. We don't send them out to tutors until after the deadline, but if you want to get in before the deadline, that's the correct side of the deadline. But we consider all the applications a gathered field, so you don't need to apply early or first or something. We'll wait until the deadline, and then we'll look at everyone together. And also we want to wait until you've done the maths admissions test, which I've got facts about now. So the maths admissions test is online. It's 2.5 hours, which is maybe a bit longer than other tests you've done, and it's got 25 multiple choice questions and 2 longer questions. This is the same format as 2024. If you know anyone who did the test in 2024, they'll tell you that they went to a Pearson VUE test centre and they did it on a computer screen, and that's what we're doing again this year. So for the multiple choice questions, you'll see a question on the screen and you'll select an answer. That's marked by giving you marks if you get the correct answer and giving you 0 marks if you select an incorrect answer or don't click anything. There's no negative marking, is what I want to stress there. I'm aware that there are other tests, like I think the UKMT in England run something with negative marking. That's not what we're doing. We don't punish you for incorrect answers. There are these longer questions where you type answers. I want to reassure you that we set the questions for that knowing that people will type answers. So you're not expected to write up lots of mathematics. You're not expected to write any difficult equations. You're not expected to type weird symbols. We set the questions because we want to see you explain things. We think that explaining your answer is an important skill for mathematicians. Not just about getting the right number, but also about explaining how you got there. On the screen, I've got an example of a multiple choice question where the answer is the answer and you'll get marks if you get it right. But for those longer questions, often they will ask you to explain or justify or show that or tell me why something is true. We've got some examples of those on the MAT website. I've got a link there on screen, maths.ox.uk/r/MAT. Swallowed my words, sorry. You can see the link there. That's got past papers, it's got resources like flashcards and revision guides and comprehensive list of what we expect people to know when they take the test. It's based on the first half of A-level maths, the content. So we've got on screen some logarithms and some polynomials. It's based on this very limited syllabus of maths. If you're studying a different qualification, then you're probably studying similar maths because we've limited ourselves, but you might like to check the syllabus list of topics there. You might like to check it against what you're currently doing in school. And if there's things you haven't covered yet, then you might like to show it to a teacher and check whether you're going to cover them quite soon. And you might like to look at the revision guides we've made to have a look at what the content looks like. If you look at past questions, you might get a sense of whether you've seen relevant things as well. Right, okay, good. We've got symmetric questions coming in there. That's always nice when people ask sort of exactly the opposite thing at the same time. Maybe there's one person with sort of getting both angles. Let's do that in a second, I think. So the mat is designed to be difficult. I know that sounds very mean, but we have to do it like that because it's people like you who are doing the questions. And if we make them straightforward so that people can just know what to do when they see the question, like perhaps when you see questions in school or whatever, maybe you just know what to do straight away. If we make them like that, then everyone gets 100 out of 100, and that's not particularly useful to us. So we have to make them hard. We have to make them unfamiliar. So we're limited in what maths topics we use, but we can make the questions unfamiliar by combining things together or by doing unusual things like putting a polynomial in the base of that logarithm. That's weird, but I think you can overcome it. The thing that usually happens is you look at a question, you realise you don't know what to do, and then eventually you work out what to do. Once you've worked out what to do, there's still a step of actually doing it, of course, and that can be non-trivial as well. But once you've worked out the first step of a plan, just trying things, even if you're not sure what the second step of the plan is, that's pretty good. There's guidance on UCAS referees on the UCAS website. If you've met the phrase UCAS referee for the first time just now, have a look on the UCAS website. So math is a non-calculator test, I should have said, sorry. So non-calculator test, and actually I don't know how I would use a calculator to help with this question. I guess I could start plugging in values of x, but my goodness, I don't want to do that. It's non-calculator, and also lots of the best questions in life don't require a calculator. Oh yeah, non-calculator test. Good. How in depth should we expect the 2 long questions? Well, there's some examples on the website. They're worth 15 marks, so 15 as a measure of how in depth the questions are. Good. Yeah, other universities use other tests, but this is ours. We set the questions. Good. Okay. Interviews. So we look at everything we've got so far to decide who to interview. That's your UCAS application, context from your UCAS referee or from your personal statement, where you might have told us facts about your education or about circumstances that we want to take into consideration. And we use all of that together to decide who to interview. So we don't have a hard cutoff score for the MAT, and we don't have a pass-fail mark there. We use it as evidence, just like we're looking at your predicted grades as evidence. We think it's really important, but it's not a pass-fail. So there's questions in the chat to say, hang on, I know 2 previous applicants and one of them's got a better math score and didn't get into Oxford than the other one. And that's because we look at other things as well. So we look at GCSE's predicted grades. And if we interview, then of course we've got experience of meeting you at interview and asking questions at interview as well. So it's not as simple as higher math score, definitely go to Oxford. Of course, higher math score is always good. We always like to see higher math scores. But we're aware that different people have had different experiences, different backgrounds. I think that's what I want to say. Good. We don't use Tamura as well. Oh, I didn't tell you the answer to the question. That was very rude of me, wasn't it? So someone just says, is the example 2? And the answer was, I think, 2, because of some repeated roots to a polynomial, but the polynomial comes from solving the logarithm. That's very nice. Okay, good. Okay. Lots of questions in chat about state schools and independent schools. We don't think it's as simple as that. We don't have a quota of state school and independent schools. I know that those numbers seem to be very interesting to the media and make a good headline, but we think it's much more subtle than that. So we look at individuals. We don't have a kind of quota of independent school students or something. We look at students. Good, right, okay, facts about interviews. And I have got an interview question. I'm going to do more of these later in the year. If you like this, then... well, I've got a resource later on I'll mention in just a minute because it's 11:15. Almost time for that Q&A. Here we go. Good. So interviews are in early December. They're academic in nature. We're going to ask maths questions to maths applicants, and they're online. We schedule Teams calls and we talk to people about maths questions. We found that we can do these online to have a discussion about a maths question just fine. It's almost better because the scheduling and sorting out who's going where to do what. It's one of the nice things about doing them like this as well is that it's easier for us to organise interviews with multiple colleges. So people who are interviewed are often interviewed by a second college as well. So a team at another college will almost always interview each candidate, so that they've been seen by two different colleges. We've got lots of things like that behind the scenes that you shouldn't worry about, but lots of things behind the scenes to compare applicants at different colleges, because we're trying to take the best students overall, and that might mean moving some people from one college to another. So we treat, if you put a college down on UCAS, we treat that as your first preference, but we admit about 25% of the people we admit are not at the college that they applied for, and they still have a great time and learn lots of maths. I think once they get here, they realise that the college that they've been admitted by is actually also great, so tends to work out. Right, okay, here's an interview question. I've got A and C as points on this parabola, y equals x squared, and I'd like B to be somewhere in between A and C, and I'd like to maximise the area of that triangle. So B is somewhere in between A and C, and I'd like to maximise the area of the triangle. That's the question, at least to start off with. The thing about interviews is, if you can do this question, then I can ask a harder one, or I can check your understanding, or help you fix a mistake in the calculation, or if you're trying a method that I know is going to be lots of work and maybe not work, then I can steer you to a different way of doing the question. I can get involved as well. The interviewers are there to help. They want to see you succeed. Most of the things that I'm doing in an interview asking questions or prompts or smaller versions of questions, trying to put someone in a position where they can have an idea, and they can make progress with the question. They can say something clever. The bar is quite low though for saying something clever. I am always keen for people to just say something true. So maybe that's checking you've understood the question and B is in the middle somewhere. Maybe that's writing down a formula for the area of a triangle, always a good way to start. You have a choice, of course, because you know lots of formulas for the area of a triangle, maybe several, but just saying true things. It's a good way to start exploring a problem. We can explore it together. So there's generally two interviewers. In an interview, usually one asking a question and one taking notes and paying attention to what's going on there. Okay, right. Oh, so yeah, we've got an approach in chat, and we'll try some parametric points. Go for it. Yes, and also questions while we're doing this. We also have no quotas for international students versus home students. We just want the people who are going to do well on our course. We're not limited in that way by any kind of consideration about fees or anything. We just decide who we're making our offers to, and then afterwards work out fees and English language conditions. Somebody else has asked about English language conditions, and for certain people not studying English at the moment, not studying in English at the moment, there are English language requirements. There's a bit on our website. I will try and get you a link to the bit on our website. But if you search for Oxford undergraduate English language requirements, then it might turn up. Right, good. Interview question. Nobody's done that very quickly. How do we assess potential? Well, often that means solving maths problems, or having ideas, or perseverance to keep going with a maths problem even if you're stuck and it's tricky. We're looking for people who can adapt ideas, who can understand things and adapt them to different settings, and people who are just fluent at solving maths problems that they've seen before. Good. Okay. Last bit then, I just want to show you some standard conditional offers. So at the end I said we make offers. Usually this is people who haven't finished qualifications yet, here's what we're normally looking for. For maths and stats, maths and philosophy, we're normally looking for A star, A if you're doing A levels, with A star in maths and further maths. Or if you're doing IB, then 39 with 766. Higher level, including 7 in higher level maths. Or for advanced hires, we know that's very complicated. Different people have access to different numbers of advanced hires. We would quite like it if you could do 2 or 3, including maths with A in maths. For maths and computer science, it's a little bit more complicated. I'm not going to read that out for you. For other courses at Oxford, you can find standard conditional offers on the website. Broadly speaking, that's supposed to be hard, but not impossible. And as I showed you before, by and large, when we make offers to people, they meet the grades and start the course. So this step doesn't seem to lose very many people. Possibly they're motivated by having an Oxford offer to make the grades and start the course. There's a question, if I apply for 2 different courses at Oxford, and I'm afraid you can't apply for 2 different courses at Oxford, you can only apply for 1 course at Oxford. Right, 25 student pay. So 25 is a very rough number for some of those courses. We're not fixed even on the number of Math and CS students we admit. We have some flexibility there. Does that include female students? Yes. Right, okay. Interviews, are you allowed to write stuff down? Yeah, you can write stuff down usually. You should also talk out loud, because if you're writing on a bit of paper, I might ask to see the paper as well. Good. And now people are doing the triangles. Good. Okay, FAQs really quickly. If you're doing 4 A levels, including maths and further maths, that's fine. If you did 1 in year 12, if you did maths in year 12, that's fine. We know these things are pretty normal. Your offer is likely to still be based on maths, further maths, and something else. We might specify which of the others. You don't have to be doing physics to do these courses. All my FAQs are about A levels. If you're not taking A level further maths because it wasn't offered, then that's not your fault. We can recommend some other maths that you might like around complex numbers, and perhaps starting with that video about introduction to complex numbers that I've just added to the Open Days page. If you're not taking A level further maths, but it was available, then my advice is to try and find out if you can start doing some further maths. If you're at a sixth form where people are doing further maths, then they might be able to do further maths with you as well. And the numbers did include, yes, including female students and international students. Questions are getting very specific. You don't need to have done Olympiads or UKMT maths. If you've done that and enjoyed it, you can tell us that you enjoyed it and you can tell us how it's preparing you for university perhaps, but you don't need to have had experience in that. You don't need to enjoy doing competition maths. Good. Let's talk a little bit about support from Oxford. We've got some options. You can have a look at the Mat live stream, for example, which is my live stream over the summer to show people about maths on the MAT. There's the Oxford Online Maths Club we're running at the moment, which has got lots of ideas for supercurricular mathematics. I've mentioned that there are some lectures on our main YouTube channel. You can actually get all of our lecture notes for our courses, a full list of things that we're currently teaching at courses.maths.ox.ac.uk. I look out for other events, look out for other stuff we're on, other stuff that's going on. And some quick ads for Maths Club. Here's me with, I look a lot younger in that screenshot, that's quite scary. Looking at which numbers can be written as the sum of 2 squares with Vicky. For the Mat live stream, I've got some examples of some maths around the outside. This is a trailer for another live thing if you enjoy this on this YouTube channel. And you can find out more by looking at the departmental website, the university website. You can email us, undergraduate.admissions@maths.ox.ac.uk. I haven't answered every question that's gone in Slido already. There's 5 A-level questions, obviously included in the 4 A-level policy. You don't have to do 5 A-levels. If you want to ask questions for the Q&A, we're going to take a short break for me to set up the student ambassadors and tutors section of this. We're going to take a short break and after the break, we're going to do some questions. So I'm going to clear, I think I'm going to clear the Slido. No, I'm going to just set the Slido to recent. So if you've already asked a question and I haven't got onto it, then maybe we'll approach it during the Q&A section. So yes, recommended books and things. I think I'm going to ask to the students in a minute. So we'll take a quick break and be back at 11 o'clock to answer lots of your questions. I'm going to be back with some students and tutors. Thank you for joining in with this Maths at Oxford talk. You've got a moment here to put the kettle on, make a cup of tea or something if you like, while I configure a Zoom call. Right, okay, good. Really good questions coming in already. We're gonna do some other questions. Okay, I just need to work out how to stop this from doing that. Behind the scenes. Here we go. Right. Okay, so back in about 5 minutes at 11 o'clock. We'll see you then for some Q&A.